Welcome to Lesson 3 of the Introduction to Python course. In this lesson, we will be discussing math with a focus on basic math in Python, the math module, and the random module. Now, previously we've seen that Python has some built-in functions. Along with these built-in functions, Python also has some built-in mathematical functions which allow us to perform various kinds of mathematical operations. Along with this, Python has some additional libraries that allow us to perform extended mathematical functionalities. In this lesson, we'll cover some of the built-in functions as well as two important libraries, which are the math library and the random library. Let's talk about arithmetic operators first. There are some arithmetical operators that are extremely used. There are some mathematical operators that we use most commonly in Python. Let's go through some of them. Let's go through some of the arithmetic operators in Python. So first we have addition. This is very simple. 5 plus 2 will return 7. Then we have subtraction. So for example, 5 minus 2 will return 3. Then we have multiplication. 5 times 2 will return 10. We have division. 5 divided by 2 will return 2.5. Then we have modulus. 5 modulus 2 will return 1, which is nothing but the remainder. Then we have power, which is 5 to the power of 2, or 5 squared, which is 25. Then we have floor division, which is 5 divided by 2, but in this case it's floor division, which will return 2. So here are some of the examples in Python. So first, we have 5 plus 2, which is 7. Then we have 5 minus 2, which is 3. Then we have 5 times 2, which is 10. Then we have 5 divided by 2, which is 2.5. Then we have 5 modulus 2, which is 1. Then we have 5 to the power of 2, which is 25. Then we have 5 floor division. So 5 divided by 2, which is 2. Now you might be wondering what floor division exactly is. Let's go to the next topic to understand floor division a little more. First, let's have a look at what the modulus operator does. So let's say we are doing as we did before, 5 modulus, there we go, 5 modulus 2. That gives us 1. So when we divide 5 by 2, we will have the remainder 1. So that is the result that is printed out. Once again, here the remainder will be 2, and that is what is printed out. Likewise, 22 modulus 4 would give us 2. 22 modulus 3 would give us 1. And 10,934 modulus 324 would give us 242. Now, if you want, you can do the actual division and you can solve it with pen and paper, and you can see that the remainders for all of these will be exactly the results that we have gotten by performing this operation in Python. Now we will get into floor division. Now, floor division is similar to regular division, but it is rounded down, which means that it is rounded towards negative infinity. So let's take a look at an example here. Let's say we are doing 5 divided by 2. We get the result as 2. Okay, now let's say we are doing 11 divided by 3. We get 3. 3 divided by 3 will give us 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 3. 3 divided by 3 Now this might seem a little confusing, isn't it? Let's have a look at a small illustration to understand how this works. Now let's say we are dividing 5 by 2. There we go. So we have 5 divided by 2. Now when we do this, we know that the quotient will be 2, while the remainder will be 1. Now if you want to continue with further division, as you probably already know, we need to add a decimal point to the quotient, and then we need to add a 0 to the remainder. So this means that the quotient now becomes 2 point something. We do not have any further digits there, while the remainder becomes 10. And this 10 becomes the new dividend. Now once again, when we divide 10 by 2, we have 5. So we add 5 to the quotient, and now the new quotient becomes 2.5, and the remainder is now 0. This is a complete division. So our quotient is 2.5. Now in floor division, this quotient will be rounded down instead of being rounded up. And that is why we get the result as 2. So instead of becoming 3, which is what we would usually do if we were rounding up a number, it becomes 2. That's all. And that's why when we did 5 divided by 2 with floor division, the result was 2. Likewise, when we do 11 divided by 3, we follow the same process and we will end up with 3. It sounds a little confusing initially, but once you get the hang of it, it's pretty easy. Now let's continue with some more examples. So let's say we are doing 22 divided by 4. It gives us 5. Now you can try performing these calculations on your own and check and see that the results are the same as what you get when you perform them with pen and paper. 10,934 divided by 324 gives us 33. Now let's try using a negative number. So let's say we do minus 5 divided by 2 with floor division. This gives us minus 3. Once again, remember, the result is rounded down towards negative infinity instead of being rounded up. Alright, so now that we have gone through some of the arithmetic operations, let's come to an exercise. Now, in this exercise, we need to write a small function which is called divide, and this function will take a numerator and a denominator and will print out a response that even a fifth grader would understand. So it has to print it out in a very easy way and most preferably in words rather than just in numbers. So this is our sample output over here, and this is the code that has been given to us already. So let's just take this code, let's copy and paste it here. Now what we need to do is write the divide function. So let's define our function. We'll call it divide. And we will pass in the parameters num and den, which will be numerator and denominator. Now we have our variable remainder equal to numerator modulus denominator. Then we perform floor division, so variable floor equal to numerator divided by denominator. Finally, we print the numerator and the words divided by denominator equals floor with a remainder of and remainder. And now the rest is all right because we have our main function already given to us. And all we have to do is just call the main function. Now when we run this code, we can see that it is given to us in a very simple format. So we have 5 divided by 2 equals 2 with a remainder of 1. Likewise, 6 divided by 3 equals 2 with a remainder of 0. In the same way, 12 divided by 5 equals 2 with a remainder of 2, and 1 divided by 2 equals 0 with a remainder of 1. This is how we can use the various built-in functions of Python to perform mathematical operations. Let's now have a look at some of the assignment operators that are used in Python. The first is just basic assignment, for which we use the equal to sign. So for example, we have a equal to 2. Then we have plus equal to, which will be one-step addition and assignment. So for example, a plus equal to 2 is the same as a is equal to a plus 2. Then we have the minus equal to operator, which is one-step subtraction and assignment. So for example, this would be a minus equal to 2, which is the same as a is equal to a minus 2. Then we have the multiplied by equal to operator, which will be one-step multiplication and assignment. So for example, a multiplied by equal to 2 is the same as a is equal to a times 2. Finally, we have the divided by equal to operator, which is one-step division and assignment. This would be, for example, a divided by equal to 2 is the same as a is equal to a by 2. Sounds a little complex, but let's just take a look at some quick examples. This will make it more clear to you. So let's say we have a equal to 5. Sorry, I have to call a. There we go. We have just done basic assignment, and we have said that a is equal to 5. Now let's say a plus equal to 2, and let's call a. So now a takes its initial value, which is 5, and it adds 2 to it, and then prints out the result, which is 7. Now let's do a minus equal to 2. And when we call a, we get 5, because a has taken its initial value 7 and subtracted 2 from it and printed the result. This gives us 5. Now when we do a multiplied by equal to 2, we call a and we get 10. So in the same way, a, which is now equal to 5, is multiplied with 2 and the result is printed out. This gives us 10. Then we have a divided by equal to 2. Now when we call a, we get 5.0. Now here's something interesting. So until here, we had gotten integers. But over here, when we find the type of a, we find that a is a float. That's because division returns a float. Now let's have a look at the precedence of operations. So the order of operations for arithmetic operators is like this. First, it would be the exponential operation. So for example, a to the power of 3 or 5 to the power of 6, things like that. Next, we would have multiplication, division, floor division, and modulus. Finally, we would have plus and minus. Now we can use parentheses to change the order of our various operations and give any other operation a higher precedence. So for example, if we had 6 plus 3 by 3, this would be equal to 6 plus 1 and will yield 7. But if we had 6 plus 3 in brackets divided by 3, this would be equal to 9 divided by 3 and will give us 3. Now, one thing to note is that operations of equal precedence are evaluated from left to right. So 6 divided by 2 to the power of 3, 6 divided by 2 times 3 and 6 divided by 2 whole times 3 are pretty much the same. Now let's have a look at the built-in math functions. So first we have int x. This will return x converted to an integer. Now 2 points to note here. So the first is that when Python converts a value, when Python converts a float to an integer, it strips everything after the decimal point. So basically it rounds down for positive numbers and it rounds up for negative numbers. Now when Python converts strings to an integer, the string object must be an accurate representation of an integer. So for example, it can be 5 like this, but it cannot be 5 with a decimal point. Now let's have a look at some examples. Let's say we have int 5. This prints out 5. Now let's say we had int and then within quotation marks 5. This prints out 5 as well. Now let's say we had int 5.4. This prints out 5. Now if we had int 5.9, this gives us 5 as well. And if we had int minus 5.9, this would give us minus 5. Now let's say we had int and within quotation marks 5.4, we would get an error. It says that it is an invalid literal for int with base 10. So basically this is what was mentioned in the second point here. That when converting strings, the string object must be an accurate representation of an integer. So we cannot have a float number, we can only have an integer kind of number. Now let's look at float x, which returns some value x, but that value is converted to a float. So for example, let's say we had float 5. It now becomes 5.0, which is a float value. Now let's say we had float 5 again, but this time 5 is in quotation marks. Once again, we get 5.0. Now let's say we had float 5.4. We get 5.4 once again because it's already a float. Now let's say we have float quotation marks 5.4. We get 5.4. Now let's say we had float minus 5.99. This gives us minus 5.99. And let's say we had float 5.99. I'm sorry, I meant to put a minus there. Minus 5.99. That gives us minus 5.99. So pretty simple, right? Now we have next the absolute x. So this returns the absolute value of some value x as an integer or as a float. So let's have a look at some examples. So we have abs minus 5, which gives us 5. Then we have abs 5, which once again gives us 5. Then we have abs minus 5.5, which gives us 5.5. And if we have abs 5.5, once again we get 5.5. Next we have the min and max functions. So the min function will return the smallest value of the passed-in arguments, while the max function will return the largest value of the passed-in arguments. Min basically finds the minimum and max basically finds the maximum. So for example, let's say we have min 1, 2, and 3. So we get 1. Now let's say we have min 3.14 minus 1.5 and minus 300. We get minus 300. Now let's say we have max 1, 2, 3. We get 3. And let's say we have max 3.14 minus 1.5 and minus 300. We get 3.14. And just remember, so the min and max functions can also take an iterable containing values to be compared. All right, now let's see the power function. All right, now let's see the power operator. So when we pass in two arguments to this power function, it is the equivalent of using the power operator. So for example, if we say power and then we provide these two arguments, base and exponent, it's the same as saying base to the power of exponent. So for example, let's say we have power 4 and 2. We get 16. Now let's say we just do 4 to the power of 2. We get 16. Now, the power operator can take a third argument, which is mod.pow, base, exponent, and mod. Now, the power function can take a third argument, which is mod. So this will be written in this syntax, power, base, exponent, and mod. And this functionality is equivalent to having base to the power of an exponent modulus the mod. So let's just have a look at an example. So let's say we did pow 4, 2, 3. This would give us a result of 1. Now let's say we did 4 to the power of 2 modulus 3. This also gives us 1. Now just a quick little note here. Square brackets in code notation indicate that the contained portion is optional. So if we see this, for example, we have put mod in square brackets. That means that this is optional and it is not a necessary argument for this function to work. Now let's have a look at round. So this function, round, with the arguments number and optionally n digits, returns a number as the number rounded to n digits after the decimal. If, for whatever reason, we leave n digits as 0 or it's just omitted, then the function rounds to the nearest integer. If n digits is -1, then it rounds to the nearest 10. Let's have a look at some examples. Let's say we have round 55 and -1. This gives us 60. Now let's say we have round 2.14. That would give us 3. Now let's say we had round -3.14. That gives us -3. Now let's say we have round 3.14 and 1. That gives us 3.1. Sorry, there we go. Now let's say we have round 3.95, 1. This gives us 4. Now finally, let's say we have round 1111 and 0. That gives us 1111. Now let's have a look at the sum function. So the sum function can take two arguments. It can take iterable, and optionally it takes start. So for example, the iterable can be a list for which it adds up all the elements. Now let's go over to the math module in Python. In Python, the math module was built in to provide us with many useful tools apart from what already exists within Python. So we'll have a look at some of the basic ones here. So first, we need to import math, like this. Import math. Now we have math imported. Let's have a look at some of the common methods of the math module. First, we have math.ceilx. This gives us the value x rounded up to the nearest whole number as an integer. So for example, if we say math.ceil, and we say 5.4, we would get 6. Now, if we say math.seal and we do minus 5.4, this gives us minus 5. Now let's see math.floor x. So this gives us x rounded down to the nearest whole number as an integer. So basically math.seal rounds up and math.floor rounds down. So let's have a look at some examples. So let's say we have math.floor 5.6. This gives us 5. Now if we do math.floor minus 5.6, this gives us minus 6. Next we have math.trunc x. X with a fractional truncated, which effectively rounds towards 0 to the nearest whole number as an integer. Okay, I know this sounds a bit confusing, but let's have a look at an example. So we do math.trunc 5.6. Sorry, there was a typo over here. 5. As you can see, it's rounded towards the nearest whole number as an integer, rounding towards 0. So that's why 5.6 becomes 5. And likewise, math.trunc minus 5.6 gives us minus 5 because once again we are rounding towards 0. Next we have math.fabs. This gives us the absolute value of float x. It's similar to the built-in absolute function that we have seen earlier, except this function returns a float, whereas the absolute function returns a number which is the same data type as x. So whether it's a float or an integer, it will be returned in the same type. So let's take a look at an example here. So if we do math.fabs of minus 5, we get 5.0. Now, if we did abs of minus 5, we would get 5. In this case, this integer becomes a float. In this case, the integer remains as an integer. Now let's have a look at math.factorial. This gives us a factorial of x. Usually it's written as x with an exclamation mark, but in Python, that's not how it's written. So let's have a look at an example here. So we have math.factorial 3. This gives us 6. Then we have math.factorial 5, which gives us 120. Next, we have math.power x comma y. This we can kind of understand. So it gives us x raised to the power of y as a float. So if we do math.pow and then we provide two random numbers like 5 and 3, we get 125.0. Then we have math.square root x, which gives us the square root of x as a float. So for example, math.square root 25. This gives us 5.0 instead of just 5. Now, the math module also consists of two constants, which is math.pi and math.e. If you are aware in mathematics, we have two constants, pi and e. So within Python and within the math module of Python, we can access those constants with the help of the math.pi and math.e functions. Now we'll have a look at some additional math methods. We won't go through this elaborately. We will just briefly skim through them. So we have some logarithmic methods. So for example, math.log x. Then we have trigonometric methods. So for example, math.sin x. Then we have angular conversion methods, for example, math.degrees(x). Then we have hyperbolic methods, for example, math.sin(h) of x. Now let's move on to the random module. In Python, the random module is used for creating and selecting random values. First, we need to import random the same way that we imported math, like this. Now that random is imported, we can use it to perform different kinds of operations. So let's have a look at the first one, which is random.random. As you can see, this has now generated some random float between 0 and 1. If we run this again, we get another random float. And let's say we run this a third time, we get another random float. And as you would have noticed, all of these floats are between 0 and 1. Next, we have, let me just get rid of the quotes out here. All right, next we have random.rand int a, comma b. So this will give us a random integer between and including a and b. So for example, let's say we have random dot rand int 1 comma 10. Now when we run this, we get 9. Now let's say we did the same thing again, we get 10. So it includes the b value that we have given. Now if we run this again, we get 5. Next we have random.randrange b. So this will give us a random integer between 0 and b minus 1. So for example, if we say randrange 22, we get 3. If we run this again, we get 0. If we run this again, we get 8. If we run this again, we get 11, and so on. Then we have random.randrange a comma b. So this will give us a random integer between a and b minus 1. So let's do random.randrange. And this time we will say 3, comma 22. Now when we keep running this again and again, we get 9, we get 16, we get 10, we get 16 again, we get 10 again, we get 8, and so on. Now we have random.randrange a, b, and step. So this will do pretty much the same thing as before, except there will be a step between and including a and b minus 1. So for example, if we have random.randrange 3, 22, and let's say we take the step of 2. So this gives us 13, 13 again, 3, 19, 21, and so on. Then we have random.uniform a comma b. So this will give us a random float between and including a and b. So for example, if we say random.uniform, and let's say we say 3, comma 22, it gives us a random float like this, 8.0296, etc. Now we also have random choice sequence and we have random shuffle sequence. So just to quickly look at this, the random choice sequence will return a random element in the sequence, while the random shuffle sequence will shuffle the sequence that is in place. Now let's move on to seeding. The random seed function is used to initialize a random number generator. So the value of a, which is given in the function, will determine how the random numbers are selected. So let's have a look at this code. So first we will import random. Then we will say random. Sorry about that. Let me convert this back to a code cell. This two. Sometimes that happens in Jupyter notebooks when you mess up whatever you type. All right. So let's say we have random dot seed 1, and then we have random dot rand int 1 comma 100. This gives us 18. Now let's say we do random dot randint 1 comma 100. This gives us 73. Now we do random dot randint 1 comma 100. This gives us 98. Now we will reseed. So we will do random dot seed 1. Then we will do random dot randint 1 comma 100. This gives us 18. Then we have random dot randint 1 comma 100, which is 73. Then we have random dot randint 1 comma 100, which is 98. If you've noticed, the random numbers that were generated as we perform this program, these depended on the seed value that is provided. Now, if we run the same code locally, we would get the same random integers. This is extremely useful, especially for testing. Now, by default, the random seed generator uses the current system of time to ensure that the seed is seeded with a different number every time that it runs it. This ensures that the random numbers that are generated each time will be different and not the same. Now let's jump into an interesting exercise. In this exercise, we will find out how many pizzas we need. So first of all, we need to prompt a user. We need to write the program in such a way that we prompt the user to input the following information: the number of people, the number of slices that each person will eat, and the number of slices within each pie of pizza. Using this information, we need to calculate how many pizzas are required to make sure that everybody is fed. So this is an example of the output that we need to get. Now let's dive into the solution. So first we will import math. Then we will define our main function. Now we define our variable people, integer, to convert the value into an integer. And then we input from the user how many people are eating. Next, we define the variable slices per person, which will be float. And once again, input. Then we ask how many slices per person. Then we define a variable slices, which is equal to slices per person times people. Then we define slices per pie, which is integer, and we input how many slices per pie. Then we define a variable pizzas equal to math.ceil slices divided by slices per pie. And then we print you need, comma, pizzas, comma, pizzas to feed, comma, people, comma, people. Then we define total slices equal to slices per pie times pizzas. Then we have slices left, which will be the total slices minus slices. Finally, we have the print where will be, comma, slices left, comma, leftover slices. So that is our function. I think the logic is pretty easy to understand. So now that we have defined our function, we call the main function. So let's input our values. So let's say there are 4 people eating pizza. Let's say each person needs 2 slices. And let's say that each pie of pizza contains 8 slices. So we find that we need 1 pizza to feed 4 people, and there would be 0 leftover slices. Now let's run this code again and see what happens when we put in different values. So let's say there are 7 people eating. Let's say each person needs 3 slices of pizza. And let's say that each pie, once again, has 8 slices. So we would need 3 pizzas to feed 7 people, and there would be 3 leftover slices. Pretty interesting, right? Now let's come to another fun exercise, which is dice rolling. So this would basically be like a die simulator. And the program would need to include 2 functions, the main function and the roll die function. Here, the roll die function should be able to take 1 parameter, which is sides, and it should return a random roll between 1 and sides. Now the main function needs to call the roll die function 3 times and keep a tally of the total. After each roll, it should print out the value of the roll and the number of rolls and the total. Now at the end, it should output the average of the 3 rolls. As you can see, this is our sample output. Let's go straight away to the solution. So first we would import the random module. Now we define our function roll underscore die, and we provide the parameter sides equal to 6. Now we have number rolled equal to random dot rand int 1 and sides. This will give us some value between 1 and the value of sides, which in this case is 6. Next, we return num underscore rolled. That's it for the first function. Now we have the main function. So we define main. We say size is equal to 6. We have total equal to 0. We have num rows equal to 1. Then we have row equal to roll by size. Then we have print you rolled followed by the number that was rolled. The total will be equal to, so we say plus equal to roll. So this will add the value to the previous value of the total. Now we will print total after first roll and the total. Now num underscore rolls plus equal to 1. Then we have roll equal to roll underscore die size once again. Then we print you rolled a roll and total plus equal to roll, and we print total after comma num rolls comma rolls comma total. Then we have num rolls plus equal to 1, and then we have roll equal to roll underscore die size. Then we print you rolled a lot of this is pretty much repeated from previous steps, so it's not too difficult. It's just a little lengthy, that's all. Then we have total plus equal to roll, and we print total after comma num underscore rolls comma rolls comma total. Then we have average equal to round total divided by num rolls 2. Then we print your average roll was, and we print out the average. And then we print thanks for playing. Some cute little message at the end. Now that we have done this, let's hope that all the steps are correct and all the values are correct, and we will run the main function. As you can see, our program has worked. So the first thing that it gives is you rolled a 1. The total after the first roll is 1. Then you rolled a 3. total after 2 rolls is 4. Then you rolled a 1, total after 3 rolls is 5. Now our average roll was 1.67. And finally, we print out the message, "Thanks for playing." So that's about it. This is how we can use both the math function as well as the random function. That's about it. This is how we can use the math library as well as the random library to perform various kinds of mathematical operations in Python. So there we have it. In this lesson, we have learned how to do basic mathematics in Python, and we have also learned how to use the math and the random modules to perform extended mathematical functionalities.